Imagine two shafts. One is solid, heavy, and looks strong. The other is hollow, lighter, and looks weaker. Now here's the surprising truth. Most high-performance machines, vehicles, and even aircraft use hollow shafts. So the big question is, which shaft is actually better, hollow or solid? And more importantly, why? In this video, we'll break it down using real engineering logic, simple formulas, clear comparisons, and practical industrial examples. By the end of this video, you'll never look at a rotating shaft the same way again. A shaft is a rotating machine element used to transmit torque, carry power, support gears, pulleys, flywheels, and couplings. You'll find shafts in motors and gearboxes, pumps and compressors, conveyors, automobiles, turbines, and generators. Now shafts are mainly of two types, solid shafts, hollow shafts. Let's understand each one first. A solid shaft is exactly what it sounds like. Completely filled material, uniform cross-section, easy to manufacture, commonly used in small and medium machines. Advantages of solid shaft: simple design, easy machining, lower manufacturing complexity, suitable for low to medium power transmission. But is more material always better? Let's find out. A hollow shaft has material concentrated near the outer surface, empty space at the center. Sounds weaker? Actually, this is where engineering becomes interesting. Advantages of hollow shaft: lower weight, better strength-to-weight ratio, improved torsional efficiency, reduced inertia. This design is widely used in automotive drive shafts, aircraft structures, high-speed rotating machinery. But why does hollow work better? When a shaft transmits torque, maximum shear stress occurs at the outer surface, minimum stress occurs at the center. This is the most important concept of this video. The material at the center of the shaft contributes very little to torque resistance. So in a solid shaft, inner material adds weight, but contributes very little strength. In a hollow shaft, unnecessary center material is removed, useful outer material remains. That's smart engineering. Torque formula: T equals /16. For hollow shaft, T equals /, where T equals torque, tau equals shear stress, D equals outer diameter, D equals inner diameter. Important observation: strength depends more on diameter than material volume. That's the game changer. 1. Strength: hollow shaft can transmit same torque as solid shaft, uses less material. White heavy checkmark, hollow wins. 2. Weight: hollow shaft is lighter, reduces load on bearings and supports. White heavy checkmark, hollow wins. 3. Stiffness: for same weight, hollow shaft has better torsional rigidity. White heavy checkmark, hollow wins. 4. Inertia: lower rotational inertia, faster acceleration and deceleration. White heavy checkmark, hollow wins. 5. Cost: solid shaft is cheaper to manufacture, hollow needs precise machining. White heavy checkmark, solid wins. Automobiles: drive shafts are hollow, reduces vehicle weight, improves fuel efficiency. Airplane aerospace: hollow shafts and tubes everywhere, weight saving is critical. Deer heavy machinery: large diameter hollow shafts used, same strength, less mass. Counterclockwise arrows button high-speed rotating systems: hollow shafts reduce vibration, better dynamic balancing. Solid shafts are better when shaft diameter is small, manufacturing simplicity is important, cost is critical, loads are moderate, speed is low. Examples: small motors, simple gear drives, workshop machines. Hollow shafts are better when shaft diameter is large, weight reduction is required, high torque transmission, high rotational speed, long shaft lengths. Examples: turbine shafts, vehicle propeller shafts, industrial gearboxes, power transmission lines. Crossmark myth: solid shaft is always stronger. White heavy checkmark truth: strength depends on how material is distributed, not how much material you use. Engineering is about efficiency, not bulk. So, which shaft is better? For same weight, hollow shaft is stronger. For same strength, hollow shaft is lighter. Final answer: heavy checkmark hollow shafts are generally better for power transmission. Heavy checkmark solid shafts are preferred for simplicity and low cost. If you found this explanation useful, hit the like button, share it with fellow engineers, and subscribe to Simple GAN for practical engineering made simple. Comment below, hollow or solid? Which surprised you more? See you in the next engineering deep dive.